Good morning, students. In this lesson today, I will discuss your homework about traveling waves, the multiple choice questions number 6 until number 14. Number 6. The equation of a progressive wave is y equals 2 times the sine of 2 pi times t over 0.01. This should be t minus x over 30. X and y is in centimeter, t is in second. The speed of the wave is how many centimeter per second? First, we have to see the equation y equals 2 times the sine of 2 pi times 1 over 0.01 t minus x over 30, and then we multiply 2 pi into the brackets, so we have y equals 2 times the sine of 200 pi t minus pi over 15x. This 200 pi is the omega, and this pi over 16 is the k. So from here we can find the velocity, because k is equal to omega over v. So v, the speed or the velocity of the wave, is omega over k. It will be equal to 200 pi over 15. So we have 3000 centimeter per second. So the answer is E. Number 7. A transverse wave is traveling along a rope. Points C and D are located at the rope, and the equation of displacement at D is given by y equals 0.06 times the sine of 20 pi times tc minus x over 10 in meter. X is the distance between CD. We want to find the direction of travel of the wave. I have made a diagram here that this is point C, the source of oscillation, and this is point D. So if we see that this k is negative sign here, has negative sign, then the wave travels from C to D. So statement number 1 is incorrect. The second one, period of the wave is 0.05 second. We want to find the period, so let's change this equation into 0.06 times the sine of 20 pi multiplied by tc minus 20 pi multiplied by x over 10. So this is 2 pi x. And omega is 20 pi. So omega is 2 pi over t equals 20 pi. So t is 0.1 second. So this statement is also incorrect. The third statement is the speed of the wave. We want to find the speed of the wave. Remember that speed is omega over k. Omega is 20 pi. The wave number is 2 pi. So v equals 10 meter per second. So this statement is correct. The fourth one, wavelength. We want to find wavelength. Let's just find it from the wave number. Wave number, or k, is equal to 2 pi over lambda. So lambda is equal to 2 pi over k, and the k is 2 pi. So lambda is equal to 1 meter. So this statement, the fourth statement, is also correct. So the correct statements is R, 3, and 4. The answer is E. Number 8. A progressive wave travels from A to B with the amplitude of 0.01 meter and the period of 0.2 seconds. The distance AB is 0.3 meters. The speed of the wave is 2.5 meter per second. We want to find the phase angle difference. So let's just write down what we know. Amplitude is 0.01 meter, period 0.2 second. Distance AB is equal to x, 0.3 meter, and the speed of the wave is 2.5 meter per second. We know that lambda is equal to period multiplied by v. So we can find lambda here, which is 0.5 meters. And to find the phase angle difference, I would like to find delta phi. Delta phi is equal to x over lambda. The x is 0.3 meters divided by 0.5 meters, so delta phi is 3 over 5. And delta theta is 2 pi multiplied by delta phi. So it will be 2 pi multiplied by 3 over 5 equals 6 pi over 5. So the answer is D. Number 9. A progressive wave directed to the right is formed on a piece of rope. 2 points P and Q are located at a distance of 9 meters. P is oscillated upwards with the speed of 360 meter per second and frequency of 30 Hz. Calculate the phase at P when the phase at Q is 1/4. First, from phi and f, we can find the wavelength lambda, which is equal to phi over f. It is 360 over 30 equals 12 meters. And then delta phi is x over lambda. X is 9 meters, lambda is 12 meters, so delta phi is 3/4. Delta phi here is the difference between the phase at P and the phase at Q. We have to write it down as phi P minus phi Q. Why? Because point P oscillates first before Q. So the phase of P must be greater than the phase of Q. So we write it down as phi P minus phi Q. Delta phi is 3/4. We want to find phi P, and phi Q is 1/4. So the phase at P is equal to 1/4 plus 3/4 equals 1. So the answer is E. Number 10. The equation of the displacement of a progressive wave is given by progressive wave is equal to traveling wave. It is equal to y equals 0.05 times the sine of 0.1x minus 20t plus pi over 3 meters. The first statement is its amplitude is 5 centimeter. We should change this equation into y equals a times the sine of omega t minus kx plus theta 0. So we change this equation into this. And then we can see that the amplitude is 0.05 meters. So it is equal to 5 centimeter. So this equation, this statement is correct. The second statement is about the frequency. And we can find frequency from the omega. The omega here is 20 radian per second. And omega is equal to 2 pi f. 2 pi f equals 20, so frequency is equal to 20 divided by 2 pi. It is equal to 10 over pi hertz. So this one is also correct. The third statement is about the wavelength. And to find the wavelength, we can see the wave number, the k, because wave number is equal to 2 pi over lambda. So k equals 0.1, 2 pi over lambda is 0.1, so lambda is equal to 2 pi over 0.1, it is equal to 20 pi meter. So this statement is also correct. The fourth statement is about the initial phase. We can see here that the initial phase angle is pi over 3. So phi 0 initial phase is equal to initial phase angle divided by 2 pi. It is pi over 3 divided by 2 pi equals 1/6. So this statement is also correct. The fifth one, its speed is 200 meters per second. We can find speed from the equation of v equals omega over k. The omega is 20 pi and the wave number is 0.1. So it is equal to 200 meters per second. So this statement is also correct. So how many statements are correct? There are 5 statements correct. The answer is E. Number 11. A point on a rope is located at a distance 1 meter from the source of oscillation. That is x, 1 meter. The wavelength is 2 meters. We want to find the phase difference between the point and the source of oscillation. Then we'll just use this equation. Delta phi is equal to x over lambda. X is given, 1 meter. Lambda is 2 meters. So the delta phi is a half. So the answer is E. Number 12. A, B, and C are some points on a rope which a wave passes through. The distance between A and B is 10 centimeters, and that between B and C is 11 centimeters. I would like to draw a diagram. A, B, C. XAB is 10 centimeters, and XBC is equal to 11 centimeters. So from A to C, it will be 10 plus 11 centimeter. Now, the phase difference between A and B is 1/7. We want to find the phase difference between A and C. We know that phase difference between A and B is phase A minus phase B, or XAB over lambda. It is 1 over 7. XAB is given 10 centimeters. So here we can find the lambda, and we can calculate lambda to be 70 centimeters. Now, to find the phase difference between A and C, delta phi A and C is XAC over lambda. XAC is 10 plus 11 divided by the lambda. We have calculated the lambda. So it is equal to 21 over 70. It is equal to 3 over 10. So the answer for this number is D. Number 13. A wave is traveling from A to B with the amplitude of 2 centimeters as seen in the figure below. The distance AB is 6 meters. AB forms 3 over 2 lambdas. So 3 over 2 lambdas is equal to 6 meters. So we have lambda, which is 4 meters. And the time needed by the wave to travel from A to B is 3 over 4 seconds. And that will be 3 over 2 period, because period is the time to do one wave. So from A to B is 3 over 2 waves, 1.5 waves. So T is equal to 3 over 4 divided by 3 over 2 equals a half second. We want to find the equation of displacement of a point P at distance x meters from B. So we have to find the value of K, which is 2 pi over lambda. 2 pi over 4 meters, we have pi over 2 meter to the power of minus 1. And we have to find the value of omega, which is 2 pi over period. 2 pi divided by a half, so it is 4 pi radian per second. And to find the equation, we know that the general equation is y equals a times the sine of omega t minus kx plus theta 0. Here, the theta 0 is equal to 0 because it starts from the equilibrium position. And the amplitude is 2 centimeters. 2 times the sine of 4 pi t, omega is 4 pi, minus k, pi over 2 x plus 0 centimeters. And the answer, if you see the options, we don't have the equation similar to this one. So we need to change this equation into kx minus omega t, because all are in kx minus or plus omega t. So we change the equation. This becomes negative 2 times the sine of pi over 2x minus 4 pi t in centimeter. You have to change the unit in the options because those are all stated in meters, while we have to have the y in centimeter. So the answer will be B. Number 14. The end of a rope is oscillated so that a traveling wave is formed with the speed of 10 meters per second, the frequency of 5 hertz, amplitude 1 centimeter. When the source of oscillation has oscillated 0.1 second, that will be the T. We want to find the phase angle of a point at the distance of 0.25 meters, that will be X. First, we have to find omega. Omega is 2 pi f. It is equal to 2 pi multiplied by the frequency, 5, equals 10 pi radian per second. And then we find the K, which is omega over V. The omega is 10 pi. The velocity is 10 meters per second. So K is pi in the unit of meter to the power of minus 1. And the general equation is A times the sine of omega t minus kx. The amplitude here is 1 centimeter times the sine of 10 pi times the time is 0.1 minus k is pi and x is 0.25 meters. So we have the theta here, the phase angle. This will be the theta. So if we have the equation of 1 times the sine of 0.775 pi The question is only about the theta. So the theta will be 0.75 multiplied by 180 degrees. It will be 135 degrees. And the answer will be D. So that's all for today. If you have any questions, you can ask me. And don't forget to do your homework for tomorrow. Tomorrow I will give you the discussion about the stationary wave questions in the multiple choice questions from your book. Thank you. I hope this video is useful for you.